Hello everyone. Today we are going to learn how to make AND gate and OR gates in two different languages, ladder logic and also SCL language. SCL stands for Structured Control Language. So, to start making a ladder logic, we normally write the program in the main OB1. We can create function blocks, but today I'm not going to go through function blocks at the moment. I'm going to write my whole program in the main OB1. And in the future lessons, I will show you how to make function blocks. So, main OB1 is basically the main organization block. And I am going to write the AND gate and OR gate in this main OB1. But before I start doing the programming, I am going to define all my tags in my PLC tags. So if you click on PLC tags and then click on default tag table, here is where you can define all your input and output addresses. I am going to start with input number 1, and that's going to be my input 0.0. If you press enter by default, basically it will pick I0.0, which is the very first input address. Let me just explain briefly how many digital inputs we've got on this PLC. I am going to show you here. So we have got this 1214 PLC here, and on this PLC we have got one full byte of digital inputs, includes 8 switches from I0.0 to I0.7. As you see here, when you activate each input, the specific LED related to the input will be activated. So now how you know input 0.0 is activated, then 0.1, 0.2, 3, 4, 5 until 0.7. So I've got one full input bit available here. Sorry, input byte available here, which include 8 input bits. And also all the outputs, which you can see at the bottom here, the LEDs, and they are all connected to these LEDs on the board here. Okay, so we have got 8 switches that we can use them as an input. I'm going to go back to the programming now. So input number 1, by default, when you press enter, it goes I0.0, but I'm going to change it to I0.1. Makes more sense. Input 1, I0.1, and then input 2 is going to be I0.2. Input 3, I0.3, and then input 4, which is going to be my I0.4. And now I am going to address 4 outputs. Output number 1. If you press enter, by default it goes for the input. However, we need to change it to an output. And also output number 1 is going to be 0.1. So that's the basically address of the byte, which is the address 0, and that's the address of the bit of this specific byte, which is bit number 1. Okay, so I've got output number 1 as Q 0.1, and then output number 2 Q 0.2, output number 3 and then output number 4. So I define all the inputs and outputs needed for this lesson. So now I can go back to my main overview. Okay. To create an AND gate with 2 inputs is quite simple in ladder logic. You can apply 2 normally open switches. You can either find it from here, or if you go to the instruction and open bit logic operation, you also can find your normally open, normally close, and other switches here. And also I need an output, so the bracket represents an output in ladder logic language. So I am going to use input number 1 as the first input, and then input number 2 as the second one, and also output number 1 is going to be my output for this ladder logic programming. So now I can simply download my program into the PLC. And also I can monitor my program. So now I have got 2 inputs in series, which creates an AND gate, and also my output. So if you want to test it, simply you can activate 2 switches. Switch number basically 1 and switch number 2. They both has to be activated for the output to turn on. And I'm going to show you here. So now if I activate switch number 1, which is I0 point number 1, the second switch, the LED turns on, and then the second switch, as soon as I turn the second switch on, you can see the output Q0.1 turns on. And now we are going to test it in the program. I'm just going to show you here. So input number 1 and then input number 2 will turn my output high. So you can see it's very simple in ladder logic. Now we are going to do the same program in a different language, in SCL language, or a structured control language. So my next network, I want to be in SCL language. So if I right click on the first network and then insert SCL network. So now in SCL language, which is quite similar to C language, it is an advanced language, and we are going to create an AND gate, which is very simple. So to create an AND gate in SCL language, we need to create a if function. So we say if I am going to use the same inputs, input number 1 and input number 2, but a different output. So input, if you are using an absolute address, which is a global address, it's better to start with a quotation. So we say if input number 1 is equal to 1, or sometimes you can write high. There is no difference. Sorry, true. So either of them will give you the same result. So if input number 1 is equal to true, if I am going to create an AND gate, as I am using at least two inputs, so I need to put each input in the bracket, and open the bracket again, quotation mark, and then as soon as you put the quotation mark here, all the global addresses will appear at this, on here, on this table. So you can pick exactly which input address you want to define. So I have used input number 1 already, and now I am going to go for input number 2 is equal to 1. 1 or true, there is no difference. Either of them will work. Then you put the semicolon, the output, sorry, I have to start with a quotation mark, then output. Output, I have already used output number 1 in the first network. So in the second network, I need to use a different output, otherwise there will be a clash. So output number 2 must be equal to high if you are going to make an AND gate. So in this case, if you want to turn an output high, basically we are writing on a specific output. So in this case, we put colon, then equal to 1. And then we close the line with semicolons. So now we need to learn. We have got two different equals. When we are going to write, basically to read an input status, we use only equal. If you want to change an output status, we need to use colon equal. So now we ending the if function. So whenever you create an if function, you have to close it at some point. So now close the line with semicolons, and now the programming is done. So now simply we can download the program. It's better to go offline first and then download the program again. So anytime you make any changes into your program, you have to download it again. And then finish. So now if I monitor the program, okay. So now here we have got two inputs, input number 1, input number 2, and then also I've got output number 2. So here we can see input number 1 at this point, input number 2 here, and then the output. So now I am going to activate each input and see what happens. So input number 1 is true now. However, the output is not true yet because it's an AND function and input number 2 has to be high as well. So now turn the input number 2 true, and you can see the output change to true as well. So that's how we can write an AND function in SCL language. Okay, I'm going to go offline again, and now I am going to show you how to create OR gate in ladder logic and SCL language. So now I am going to create a network